Okay, let's try the last question here. Let's read all the stuff first here. It says in the diagram, O is the center and E is the midpoint of AD here. So those two sides are equal to each other. We're going to need that, I think. And the other thing that's real important is that this CG is a tangent line, that's a tangent line. They give us that O3 is equal to X, and then that's pretty well the stuff we need to be able to do this question. Now they say, why is EOCG a cyclic quad? Well, I don't know, but let's see here. Hey, we know that's 90 degrees right off the bat. Isn't this a line from the center to the midpoint? That's 90 degrees. Oh, two 90s make 180. That's why it's a cyclic quad. That's all it is. Now, I wouldn't get it that fast. I'd have to look at it and think, and the more you do it, the faster you get it. But anyways, it's a little bit tricky sometimes. But C3 is 90 degrees. Tangent is perpendicular to radius. E2 is 90 degrees because a line from the center to the midpoint is 90 degrees. Well, that means EOCG has to be a cyclic quad because of the converse of opposite angles in a cyclic quad being supplementary, adding to 180. And there it is, all done. Now write down with reasons two other angles that equal X. Well, I have this in here a little bit too early here, but you can see right away the O3 is X, gee, O1 must be X, vertically opposite angles. Well, that was pretty easy. But now you often use the thing from before. We know this is a cyclic quad. There's really a circle we could put through E, O, C, and G. Well, there's a line going straight off. X is an exterior angle, and it equals the opposite interior angle in the cyclic quad. So G must be X, the exterior angle of a cyclic quad. And that's it. That's the whole thing done. Well, at least question 2 done. Now, how are we going to find A1 in terms of X? Well, here's an angle at the center X, and this A1 up here is opening up to the same segment that's opening up from the center. It must be half of X over 2. In fact, that's what A1 is, X over 2, because the angle at the center is twice as big as A1, an angle at the circumference. Now, how could we figure out what C1 is? Well, if we've got A1 is X over 2, that's a tangent. C1 is an angle between the tangent and the chord. It's got to equal A1. So C1 must be X over 2, the tan chord theorem. Well, we're almost finished here because all we've got to do now is C2. Well, there's C2, but hang on, aren't these two radii equal? It's an isosceles triangle. So it looks like B2 has to be, these two have to be the same. So B2 and C2 have to be the same. And it's got to add up to, all of this has to add up to 180. So if C2 has to equal B2 because of angles opposite equal radii, 2C2 plus X has to add up to 180, the angles summing in triangle BCO. Well, all we do is subtract X and then divide by 2. We get C2. C2 must be 90 degrees minus X over 2. See, we divided by 2. I subtracted X and divided them both by 2, put the positive thing first, and there I've got C2 in terms of X. All done.